Hello, this is Mr. Wynn. Today's video will be about quadratic inequalities. So this is the same thing we've always done. Basically graph it, figure out if it's solid or dotted, and then try a test point. If it's true, shade with the test point. If it's false, shade without the test point. So graph and solve this quadratic inequality. So first I want to graph that. We know that the y-intercept is at 1. Because that's the c, because this is standard form. Also, I need to find the vertex, so I'm going to do negative b over 2a. So I do negative b over 2a. That turns into negative 2 over 2 times 1. So that's negative 2 over 2, which is negative 1. That's my x for my vertex. I'm going to plug that in. So let's go a different color. So y equals, x is negative 1 squared plus 2 times negative 1 plus 1. That's positive 1. Minus 2 plus 1. 1 minus 2 is negative 1 plus 1 is 0. So I know my vertex is negative 1 comma 0. If you completed the square, got in the vertex form, you would have got that as well. Anyways, negative 1, 0 is right here. That's my vertex. And my y-intercept is 0, 1 is right here. So it helps y'all. Remember, it's reflected over this line. So there's a point right here. And make a U, and this time it's dotted. I'm going to get rid of this line because it's bothering me. Alright, now, so after I finish graphing it, I need to do a test point. 0, 0 is the best one. As long as it's not going through 0, 0, we could use it. So I'm plugging 0, 0. So into the original problem, for y it's 0. So for x squared, 0 squared plus 2 times 0 plus 1. That's 0 plus 0 plus 1. 0 is bigger than 1. That is false. Since it's false, I shade an area without the test point, without 0, 0. So this time it's inside the U. And that's my answer. Anything inside that picture will make the equation true. Number 2, again, graph and solve the quadratic inequality. This time we're going to have a y. So the last time we had y, so it's actually a picture on the coordinate plane. Here I don't even need a number line, but you can still graph on the coordinate plane. So this time I'm going to solve by factoring. So you now factor. I'm going to do the x method. Two numbers I multiply to negative 8, but add to positive 2. Well, to get 8, I do 1 times 8 or 2 times 4. Do any of those give me 2? Yeah, this one does. To get positive 2, I need a positive 4 and a negative 2, because 4 minus 2 is 2. So this side really, the equation is really x plus 4 times x minus 2 equals 0. Or if you want to, you can actually just put the sign there. Remember, we chose equals 0. Since it's in factored form, we can do the 0 product property. So each factor equal to 0. And solve each one. So this x is negative 4. This x-intercept, or this root, is positive 2. So I have a negative 4 somewhere. I have a positive 2. And my a is positive. That means it should be a regular u. It's not flipped. So I know my vertex is between them halfway. Technically it's at negative 1. And this is a dotted line. Now I don't know where this bottom is, but I know it's somewhere there. It's not drawn to scale. Here's my picture. Now I do a test point 0, 0, because that's inside, that's usable. 0 for x, so 0 squared is just 0. Plus 2 times 0 is just 0. Minus 8 is less than 0. Negative 8 is smaller than 0. That's true. So I shade with the test point. Here I shade inside here. Now the only difference in this problem is there's no y. I don't need the y part. I only care about the x. So really it's just the x-axis. So we're asking where on the x-axis is the answer. It's in this middle part between the two. So x is between, and it's not equal to, it's dotted, negative 4 and positive 2. That's my answer. Alright, because the other part, the outside, left of negative 4 is not shaded, right of positive 2 is not shaded. The outside of the U is not being shaded. Alright, this last one. Solve this algebraically. We could do the same thing as before and graph it and figure out where on the x-axis it is, but this time I'll do it algebraically. So we always need to get 0 on one side. So I'm going to subtract 18 both sides. Here's my brand new problem. Now I'm going to, again, factor, do the x method. So I need two numbers that multiply to negative 18 and add to negative 3. Well, 18 is 1 times 18, 2 times 9, 3 times 6. Can any of those get me 3? Yeah, I can use 6 and 3. To get a negative 3, I need a negative 6 plus 3. And those two do multiply to negative 18. So this problem is the same thing as saying x minus 6 times x plus 3 equals 0. Again, 0 product property, set each factor equal to 0. So x minus 6 equals 0. X plus 3 equals 0. So x equals 6. X equals negative 3. Now I would want to graph that on a full number line like this, but we're going to worry about the x-axis. So I'm going to do the sideways axis only. So somewhere on there is a 6. I'll call it right here. And there's a 3. Do this. So there's a 6. There's a negative 3. And it goes forever. So let me do this at the side as well. So here's a mini picture if I would in the whole thing. We know there's a negative 3 and a positive 6. And it's solid dots. I know A is positive 1, so it's a regular U. Should look something like this. So I'm allowed to do the 0, 0 test point, see if it's true or not, and then I'll be done the problem. But if you don't draw the whole picture, you don't do the x and y axis on the coordinate grid, you have to test every section. There's a section left of negative 3. This is the left section. There's an area in the middle between negative 3 and 6. That's the middle section. And this area to the right of 6. That's the right section. We pick 1 point from each one and plug it in and see if it's true or not. If it's true, that section must be shaded. If it's false, that section should not be shaded. So left of negative 3, I'm going to pick negative 5 as a test point. If I plug in negative 5 for x, I'll see if it's true or not. So negative 5 squared minus 3 times negative 5 minus 18 is less than or equal to 0. Negative 5 squared is positive 25. Negative 3 times negative 5 is positive 15. Minus 18 should be less than 0. 40 minus 18 should be less than or equal to 0. 22 is smaller than or equal to 0. That is false. Since it's false, I do not shade that left section. That was false. Now I try the middle section between negative 3 and 6. Well, the best test point guess would be 0. So I'm going to try that. I'll do 0 squared is 0. Minus 3 times 0 is 0. Minus, well, actually, I'm going to use the original problem. Is less than or equal to 18. Well, 0 minus 0 is 0. 0 less than or equal to 18. That is true, so I do shade this between here. That is shaded. And these are closed. And the last one, try something on the right of 6. I'll pick 10. It's easy to use. So I plug it into the original problem. 10 squared minus 3 times 10 should be less than or equal to 18. Well, that is 100 minus 30 should be less than or equal to 18. That is 70 less than or equal to 18. That is false, so I do not shade the right area. So only this middle part's the answer. So I'll say x is between negative 3 and 6, and it is closed. Now, if you just did the test point 0, 0 and plugged it in, 0 minus 0, 0 is 0. It should be less than or equal to 18. 0 is smaller than 18. That's true. You would have shaded inside here. You would have known that the answer was between these two numbers and not on the outside. So your choice, you want to do just one axis or the whole thing. All right, I'll leave you with this problem. Graph it. There's the answer. If you can do that, you should be fine for the quiz in class. All right, this is Mr. Wynn. Thanks for watching. See you in class.